Good afternoon.
Good afternoon.
Okay, so last class, we talk about the repeat decision. So if we have, if you need to constantly making a decision, and if the answer is yes, and then you will keep doing the same action or instruction, we will use the while loop, right? So here is our model, right? So we have while, and then we have our yes/no question, and the answer is yes. It will go through wherever the action you want it to do, and it will keep going through the question, right? Going in the loop until the answer to the yes/no question is no. Then he will move to the next instruction, right? So there might be some other instruction after the while loop. Now for the simple decision, like what we did before with the if statement, the yes/no question, right? It will only get asked once, right? If the answer is yes, then you will go to the instruction, then do whatever it asks you to do, and then you will just move on instead of going back to the question and then do it all over again, right? So here is the so that's a difference. And if you look at the chart, the flow chart, you can see the while loop, right? There's 4 lines to it, and for the simple loop, for the simple decision, your yes/no question here, there's only 3 lines going in and out from it. And the last example we did last class is we did something where we eliminate a attempt where user allows to do something. Right, then we will keep track of how many times the user failed, and then if it hit the limit, then we will terminate. We will stop the program. Now let's say we want to ask C++ to say hello 10 times. And how can we do that? And again, some of you might immediately say for loop, and keep in mind we haven't introduced for loop yet. Okay, so we will use so we will still use the while loop, but how can we ask C++ to say hello 10 times? What do we need here?
Need a counter.
Okay, so we need a counter. And what do you want to set counter equals to?
0.
Okay, so you can start with setting counter equals to 0. Now, what's your question?
While counter is less than 10.
Okay, so you want to ask, is your counter less than 10? Now, if the answer is yes, C++ will print out hello. Now, after C++ print out hello, what else do we need to do?
Update the counter.
Okay, so we need to update the counter, which we need to increase it. Right, so we need to increase the counter. And once we increase the counter, we will go back to the question and start all over it until the answer is no, which we pretty much will just finish our program here. Okay, so the code will look like this. So you will declare a variable counter. Let me just use C. Now in our loop, while C is less than 10, we will print out hello.
Shouldn't C be 0?
Yes, we can set C equal to 0. And we need to increase the counter. You can have C equals to C plus 1. Then we will finish our code here with return 0. Now I see people asking, should we put our question here to be on C less than or equals to 10? So that will depend on what do you initialize your counter. Right, so here, right, we start the counter with 0. So while our counter is less than 10, so if it's not yet 10, we will print out hello. So it will stop when the C equals to 10. That means you already have hello 10 times. So you start with C equals to 0, and then 0 is less than 10, and you will print out hello. And you already have 1 hello, so you will increase the counter to 1. So you keep doing it until you have 9. 9 is less than 10, and they will print hello, and that will be the 10th hello you print. And now your C is 10. Then when you keep going back, now when you see is 10, 10 is not less than 10, so which means you already have 10 hello already. Now you will have C less than or equals to 10 if your C start with 1. So it depends what index you assign to the counter. Right, so if you start from 0, and I see people say 0 to 9 are 10 numbers, so you will print hello 10 times. Okay, so if we quickly put the code in. Okay, so here is our code. And then we'll compile it, it will print hello 10 times. So here we see that we can use a while loop not only to create like a repeating decision, you can use it for repeat action. So the difference is if you know how many times you want to do certain thing, you can set up a counter. Then your yes, no question will be based on the counter. You will check, is your counter valid? If your
Professor,
counter,
could you move the, yeah, thank you.
okay, so for repeat action to use the while loop, we will set up a counter to keep track of how many times you are repeating the decision. Then you will test, you will have your yes, no question based on the counter. So pretty much you ask, are you there yet? If not, you will go in and then do whatever the action you want to repeat and make sure you do change your counter. Because if you don't change your counter, then your number is not changing. And every time when you test the counter, the answer is yes, then you will run into infinite loop, right? So the flow chart is like this. You will set up the counter, you will test the counter, and then you will have whatever your action you're trying to repeat, and you will need to change the counter before you're going back to the question. And when the answer to the question, right, if the counter is not valid, then you will just move on to the next instruction. Now here, example 2, you want to print the qubits of 1, 2, 3 up to 10. Which means you want to print so 1 cube is just 1, and 2 cube is 8, 3 cube is 27, and so on. And then you have 10 cube will be 1,000. So how do we code this?
Start the counter at 1.
Okay, so we can start the counter at 1. Then what's our question?
While C is less than or equal to 10.
Okay, so while C is less than or equals to 10, so this is our question. What will you do?
C out C times C times C.
Okay, so we have C times C times C. And let's say you will just put a space between them. So you will have the 10 cube in the same line. Okay, so this is the repeat action. And what else you need to do?
Increment the counter.
So increment the counter. So we have C equals to C plus 1. And then that will be the looping part. And the answer is no. We will just move on. Now, since we put in the same line, we should just, after you print out the 10 qubit, you need to end the line. And then you can return, or you can end the program. Okay, so let's put the code in. So when we run the program, right, we see the qubit from 1 through 1,000, right? So the 10 qubit.
Please show the code one more time.
Okay, so if you look at the code, right, first we initialize the counter. Right, so first we initialize the counter, right? And then our question will be, is the counter 10 yet? Right, so because we need to print the qubit from 1 through 10, right, including the 10. So your question will be, is C less than or equals to 10? And so it will print out the Q has C times C times C. Or you can use the caret. And then we will increase it by 1. Right? And then we will just put like a space between this since I don't want it to have 10 line. I want to print it in the same line. So I just put space to separate each qubit. And then you increment it, and that will be the root part. Right? So once your answer is no, you will go on. And since we print our solution in the same line, we need to end the line. Otherwise, our Venus heading will be right next to, in the same line as the 10 qubit. And I see people asking, why do we multiply it 3 times? Because the question is asking to print the cubes of the number. Okay.
Professor, I have a question.
Yes.
When you put the counter, is it like always equals 1 or does it change?
It depends the question, and it depends how you want to set up the question. Right. So in the previous example, you can use C to keep track of how many times you say hello already. So if you initialize it as initialize C as number of hello you have then you can start with 0. So when C is less than 0, that means if your counter is not 10 yet, you will print hello. So then that will be C strictly less than 10. Now, if you want C just to be like an index, like, oh, this is my first hello, and then you want to print the second hello, third hello, up to the 10th hello, then you can initialize C to be 1, and then you can end at 10. Then that will be, you will start at 1 and then end at C less than or equals to 10. So it really depends on how you want to set it up. Right, so for this question, right, since you want to print the qubit and you want to print the qubits of through like 1 to 10, so it's just easier to set up your counter at 1 and then end at 10. Now, for example, if you want to print the qubit from 100 to 111, then I can modify my code. So instead of, let's say, printing the qubit from 1 to 10, I want to print from 101 till 111. Then you can also have your counter start at 101 and end at 111. Now, if you see like the number here are 101 cube, 102 cube, 103 cube, and so on. Okay, so you don't need to always start at 0 and 1. So it really depends on the question. It depends on like how you want to set up. Right. So for example, if you want to print the qubit backward, right? If you want to print the qubit from 10 down to 1. So you want to print 1,000 first, and then 9 cube, and so on, and then down to 8, and then 1. Then you can start your counter at 10, and then you will keep subtract the 1 until you hit before 0. Does that make sense?
Yeah, thank you.
Okay, so before we move on to the next exercise, because the next few exercise, can you show it the example backward? Okay, so let me just copy our example 2 again. Okay, so this, right, is our code. If you want to print the qubit from 1 through 10. Now let's say you want to print the qubit backward, right? Start with 10 cube and then down to 1. Then you will have, then you will start with 10 and you will stop when your counter reach 1. So if your C is greater or equals to 1, if it's not 1 yet, then you will keep going into the loop. Now now you need to change the counter. Now instead of increase the counter, since we start at 10, you want to print the qubit backwards, so it will be smaller and smaller. Then you need to subtract the 1. Then you will change your counter by C equal to C minus 1. Right, so here's our code. And then when I compile it, you see it print the answer backward. It print the cube backward. Now, before we move on to the next exercise, because the next few exercises will be about dealing with numbers and digits. Now, what operation will give you the last digit?
Mod.
The mod. And what modulars are you doing?
Mod 10.
Mod 10. So if we have, like for example, if we have a number n, where n is 197.53. And if I want to get the last digit, that will give three. Right, which means whenever you divide that by 10, whenever you do the modulo 10, it will find the last digit. Now, if you have n over 10. What does that give you?
$1,975.
So you have 1975, which it will drop the last digit. So the reason I bring this two operation up because you will use it very often if you want to get access with digits. Or if you are doing some program with the integers and digits, you want to do something about it. And this too is a very common operation you will use. So if you look at the next example, you will ask user for a number that's at most 3 digits.
I think the terminal is blocking the, yeah.
Okay. Did everyone see this before? So for the 197.52, if you set n equals to that, when you do mod 10, that will give you the last digit, right? And then when you divide the 10, it will drop the last digit. So when we have when doing the integer operation. Now, if you look at the example 3, so if you want to ask a user for a number that's at most 3 digits. Now, if the user gives more digits, more than 3 digits, then you will chop off the extra digit, which means you will keep only the first 3 digits the user input. Now, how can we do that?
Divide by 10 3 times.
Do we know how many times we divide?
Divide by 1,000.
Okay, if you divide it by 1,000, that's same as dividing by 10 3 times. Do we see that here? We want to keep only the first 3 digits, right? If the question asks you to keep the last 3 digits, it will be easy, right? You can just simply find it using the modulus, like mod 1,000 give you the last 3 digits. But here, you want to keep the first 3 digits. And keep in mind that you don't know what will user input. Right, so if you look at our example before, we have n equals to, and we will have n equals to 197.53, right? So we have 5 digits here. That means we need to chop off the last 2 digits. Right? So if you look at that here, right, it's too many digits, right? So you need to get rid of the last digit, still too big, get rid of the last digit. And then you want to end at 197.
Also keep going until your n is between 0 and 999.
Okay, so you'll keep doing it until your number is in the proper range, right? So if your number is already less than 3 digits, you pretty much don't need to do anything, right? Since you will have whatever your digit, right? Since the question here is asking for a number that's at most 3 digits. It's only when the user gives more digit we need to do something. We need to get rid of the last few digits or the extra digit. And I see people say divided by 100. Now that will work if the user gives a 5-digit number and you know to get rid of the last 2 digits. Now what if the user gives a 4-digit number, a 10-digit number?
Can't we use if for this? So like if it's higher than 99, then it would do n divided by 100.
Well, that means you are only chop off the last 2 digits. Right? So let's say my n is 2341. Now this is greater than 999. Now if you divide it by 100, you will only left with 23. But if the user gives more than 3 digits, you want to chop off the extra digit, which keep the first 3 digits. Right? How do we know when to stop? Right? So we know we need, if the user gives too many digits, we need to get rid of the last few digits. Right? So let me erase that. Okay, so let's say we have this number. Right, so this is a 6-digit number, and we know it's too big, so we will get rid of the last digit. Now, when we get rid of the last digit, it's still too big. So you get rid of the last digit, still too big. So what do we notice here? So we'll keep getting rid of the last digit until our number is less than 1,000. So if your number is greater than 1,000, you will get rid of the last digit. Now, if the inputs are really less than 1,000, which means it's at most 3 digits, then you don't need to do anything. Right, so this is a repeat action, right? Because you need to keep getting rid of last digit until your number is good, it's in the proper range.
So you have to use a loop for this.
So we need to use a loop for this. So what do we need, right? So first of all, we need a number. We need a number n. So the first thing you need to get the number n. Right. Now we will get into a loop. Now what would the question be?
Is it possible? What would you do if the user entered like a negative number? Can you do modulus with negative?
We could do modular with negative, but here we assume the input is like a positive number, like or non-negative number. If you want to have the negative thing, then you just need to have like a extra
like an if statement to check.
No, you just in your question, your yes no question, you need to check both sides. So it's not only your number. If your number is greater than 99, like 999, or if your number is strictly great, if your number is greater than 999, or your number is less than negative 999. So you pretty much do it both ways, like the positive and negative. But here we assume our number is not negative. Okay, so I kind of give the answer away. So the question here is your n too big? Now, how do we define too big? Is your n greater than 999? So if your number is greater than 999, then you have more than 3 digits. So if that's the case, you need to chop off the last digit. So you have n equals to n over 10. So that will get rid of the last digit. So that will be the action you're trying to do, which you chop off the last digit. And that also kind of change the counter. If you look at here, the n here is our counter. That's what our question based on. And then we will chop off the last digit. That will also change the counter. And then we will go back to question. So you keep doing it until your number is less than 999. So here we need to declare a number n, and then we need to get the number from the user. So before we do that, we need to ask for it. So we'll see out, enter a number with at most 3 digits. And then we will take in the input. We will store it to the n. So that's how we get the n. And we will check the value. We'll check is n greater than 999. Like, is it too big? If it's too big, we will chop off the last digit. And that's your action, and also change the counter. And then you will tell the user what's their number. Okay, so you can tell them your number is, and then you will print out the n. And then you will return there. I see people say, do we need bracket in the while statement if we only have one common? You don't need it, but there's nothing wrong if you put it there. Just in case later, if you want to do more action, if you want to add like 1 or 2 instructions, you don't need to, like, you won't forget the bracket. So it's always safe to put the bracket in. But if you only have one comment, you can, you don't need to have the bracket.
Wait, Professor, I have a question.
Mm-hmm.
Like, towards the end of the code, what does the n divided by 10 really do? Is that for like if it's less than 3 digits or?
Okay, so if you look at the code here, right? So here, right, if it go into the loop, it will get rid of the last digit for you. And it will only go into it if your n is greater than 999, which means it will only go into it if your number has more than 3 digits. So if you look at it here, right, our example here, you have 19, 23, 45. It's 6 digits, more than 3 digits, like more than 999, you get rid of the last digit. And then we'll go back to the question. You have 192, 34, you have 5 digits, greater than 999. So you will go into the loop, get rid of the last digit. Now your number is 1923. So you will go to the question again. It's greater than 999, get rid of the last digit. And the next you have 192, right? And 192 is less than 999. And if your number is less than 999, it won't go into the loop. So you will finish our while loop here, and then we'll move on to the next instruction, since the answer to our yes, no question is no, right? Since 192 is less than 999, so we'll just move on. Now I see people say when you input like probably 10, 9 there, you get 214, and I see people answer there because every data have a certain capacity. So if your number is too big, the integer, like your integer variable is not big enough to store your number. So there will be an overflow. So it will have like an overflow there, like some of you mentioned there. Okay, so the capacity of the integer is 2 to the I believe 32 power minus 1. So since your number is too big, it only stores up to that number. So they probably take the input as the largest integer capacity.
Professor, I have a question. So how did you assign the CIN in this code?
You mean this line?
Yes.
Because we want to get input from the user. Right, so when we run it.
So what about the COUT?
That's cout that you print out to the screen. Wherever thing you see here, it will print to the screen. Right, so if you look at that or when you run that, it will print out wherever you say cout to, right? So we ask it to print out enter a number with at most 3 digits. So when you run that, you will see that. You will see that in the screen, right? And since it asks us to enter a number, then we'll just enter that. So let's say we have 1, 2, 3, 4, 5, 6, 7. So let's make it 7 digits. And then I will hit enter. And once I hit enter, it will store this number into my N. That's why I need to have the CN, take the input from the user. And then it will do the operation we asked it to do with the while loop. If your number is more than 3 digits, it will keep track of the last digit until your number is 3 digits. So you will have your number is 1, 2, 3, only the first 3 digits. Any questions here?
No, it's fine, thank you.
Okay, so let's do another example. Let's say we asked user for a number, and let's say it's positive.
Can you lower the terminal?
Yeah, the terminal is blocking this.
So we assume the number is not negative. Okay, and we want to print the number backward. Right, so for example, if our number is 1, 2, 3, 4, 5, you want to print 5, 4, 3, 2, 1. So how do we do that?
extract each digit and then add it to the other one and then multiply by 10.
Okay, so if we look at the question, we can make it easier since he only asked us to print it on the console. So to the user, you don't know, you just print out the number or it's an integer. So you can just print it out. And I see people say using the modulus. So since we want to print it backward, right? And that means you need to get each digit out. So for 1, 2, 3, 4, 5, that means your goal is to print 5 first, and then 4, 3, 2, and 1. And we assume that our number here is positive.
Yeah, so you can make another variable and store the 5 and then multiply by 10 and then add the 4.
So what we can do is that we can get the last, since we want to print 5 first. So if this is n, we can just see out n mod 10. That will give you the last digit. Now you will keep doing it until you have no more digit left.
Oh, so you don't care about actually having the number, you just want to output it?
Yes, so for this question, it only asks you to print it. Right, it asks you to print it backward.
It would be harder if they actually wanted you to get the integer.
Okay, so let's just print the digit first, it's easier. And okay, so first we need to declare a variable, and then we need to ask the user for it. So we'll say enter a number. And then we will get the variable store in n. Now, when do we know there's no more digit? Or I guess a better question, how do we know to get the last digit? Like, how do we know we reached the last digit?
When n divided by 10 gives you 0.
Okay, so when divided by 10 give you 0. In other words, pretty much your number need to be greater than 0. Do you see that? Because your first digit will not be 0, right? Since we asked for a positive number. So as long as your number is greater than 0, you will be able to get the last digit out. So your question will be, is there anything left in your number, right? In your number, which means your number is greater than 0. Then you will do is you will print out the last digit. Now, how do we change the counter?
Divided by 10.
So we'll divide. So divided by 10 will get rid of the last digit for you. And we'll keep doing it until you got nothing left. And since we print it in the same line, since you want all the digits right next to each other, right after that, you need to in the line. We used the variable n. So the counter here is n. And now we enter, so run it, and they ask us to enter a number. So now let's say we have 1, 2, 3, 4, 5. It will print the number backward. So it will print 5 first, 4, 3, 2, 1. So you will just print one digit at a time instead of figure out what's the backward of the number and then print it all at once. So it will print it digit by digit. Now it will be different. It will be a little harder if you want to find the integer that's backward of your input. Now it's still doable because what you do is you will have like a backward version of n. So let's call it. So let's say you have your answer, and you will start with let's do it. You can start with the 0. And the idea here is you want to get the first digit. Or if your number is only 1 digit, then the backward of it is still 5. Now, our question here is n greater than 0, because that's how we know do we want to go into the loop. Now we want to get the last digit out by n mod n mod. So n mod 10 give you the last digit. Now you want to have that digit first. So you start with 5. Now your next digit is 4. Now you will print that after wherever you already have. So what you had before, you need to shift one digit to the left. Right, so let's say you want to add the 6. You have the 5. So that means this 5 need to shift a digit to the right, and then you will add the 6 in. Now to do so, this 5 pretty much become 50. Now you will have a new digit 6.
You mean 4, right?
So you will have the last digit plus whatever answer or the temporary answer you had before. You need to shift a digit to the left, which you can do it by multiplying by 10. You can multiply by 10, it will give you a 0 at the end, and then adding the last digit, that's pretty much replace the last digit. And you need to initialize your answer at 0.
Isn't it a 50 plus 4?
Yes, this should be a 4. Good. So if you want me to modify that code, this is example 4. Then we will need to also declare, let's say, or answer. It will initialize with 0. And while instead of print out the last digit, you will have unst equals to wherever you answer, you will shift it to the left plus the last digit. And then you will print out the answer. Now if I run it, okay, so we enter 1, 2, 3, 4, 5, you will also get 5, 4, 3, 2, 1. But this is an integer. Where before we just print one digit at a time. So the only difference is you need to declare like another variable to store your answer, and then you will get one digit at a time. Right, so wherever you have there, you just keep shifting to the left. So you will start with a 0, and then you will replace it with, okay, so when you did not read any digit yet, your answer is 0. And once you point it at 5, then you will have wherever your original answer times 10 plus 5, so you will get 5. Now, once you read the 4 in, you will multiply this 5 by 10 plus the 4, and that will give you 54. And once you read the 3, you will multiply 54 with the 10, and then add the 3, so you will have 543. And then when you read the 2, you will multiply 543 with the 10, and you add the 2, write the new last digit, and then you will have 5432. Until you hit the last digit, you do the same thing. Good. And I see people asking, what does the modulo mean? The ampersand means the modulus will give you the remainder. Now, if you want to get the last digit, you want to divide it by 10. When you divide it by 10, wherever the remainder shows you what's your last digit of your number. So mod 10 will give you the last digit. If you just divide it by 10, it will get rid of the last digit. Okay, we will end the class here. The code is here. And I will see everyone Thursday.
Thank you.
Thank you.
Bye. Thank you, Professor.
Okay, I see people asking, what if one of the digits is 0? It will still work if like it's in the middle of your digit 0, since the last digit is 0. So when you do a mod 10, you still get 0 as your answer. So if you just run it, I think this is the 4B version. So let's say you have 102, 03, 04. You will get 403, 02, 01. So it will still work. Okay, have a nice day.